If there's one thing that we all learn as kids, it's don't play with fire. But apparently someone forgot to tell NASA because last Sunday they launched a $1 billion mission to literally touch the sun. It's called the Parker Solar Probe, or PSP, and after a couple minor hiccups with the launch, its 7-year mission has officially begun. Over the course of its mission, the spacecraft will come as close as 6 million kilometers to the surface of the sun. That's more than 35 million kilometers closer than any previous mission, and it will put it within the sun's outer atmosphere called the corona. There, it will study the process that creates the solar wind, a stream of charged particles that constantly streams out of the sun's surface in all directions. After almost a decade of development, the probe was originally supposed to launch on July 31st, but the date was pushed back to August 11th because of minor technical issues with the Delta IV Heavy rocket carrying it into space. Then, 2 minutes before liftoff on the 11th, there was a small problem with the rocket's helium pressurization system that stopped the launch. It took longer to fix than the hour-long launch window allowed, so mission controllers had to try again the next day, and that time, everything went smoothly. It's not too surprising that there were some kinks to iron out because this was the first launch where the Delta IV Heavy had an extra third-stage booster attached. The rocket needed the extra power to get the probe on the right trajectory because it's an unusual one. It might seem counterintuitive, but in many ways it's actually harder to travel towards the sun than away from it. Objects traveling toward the sun are pulled faster and faster by its increasingly powerful gravity, making even the smallest course changes difficult. To help counteract this, the PSP will use flybys of Venus to help control its speed and trajectory. Normally, planetary flybys are used to add energy to a spacecraft through what's sometimes called a slingshot, but each of PSP's 7 Venus encounters will be carefully arranged so the planet's gravity actually decreases the probe's energy, causing it to fall into smaller and smaller orbits. And all those orbits will be highly elongated, allowing the probe to spend most of its time farther from the sun and ensuring it doesn't spend too much time too close. At its closest approach to the sun, PSP will reach speeds of up to 200 kilometers per second, making it the fastest human-made object in history. That's more than 200 times faster than a bullet leaving a rifle. And it's good that it will be going so fast because the only thing more extreme than its speed will be its temperature. Within the corona, the sun-facing side of the spacecraft will reach around 1400 degrees Celsius, which is about the melting point of steel. Protecting it from that inferno is a shield made of super light carbon-based material. At just 11 centimeters thick and consisting of 97% empty space, the shield is incredibly lightweight. It contributes only 73 kilograms to the probe's 685, but it's strong enough to keep the probe from melting into metal slop. Even with this protection, though, the PSP will need to spend most of its time farther from the sun, where it's at least a little cooler. If all goes well, the mission should make its first pass by the sun in November, but we'll have to wait until 2024 for the close approaches that will really put its shield to the test. The Parker Solar Probe may soon be the closest spacecraft to the sun, but NASA's New Horizons mission is proving that the farthest reaches of the solar system are just as fascinating. You may remember New Horizons for its flyby of Pluto back in 2015, but since then it's raced more than 1 billion kilometers farther from the sun. And in a paper published last week in the journal Geophysical Research Letters, scientists used its data to explore a mysterious glow coming from beyond the solar system. Filling the space between the planets is a thin fog of gas and dust astronomers call the interplanetary medium, or IPM. New Horizons sees this fog as a faint ultraviolet glow all across the sky, which comes from sunlight scattering off the IPM. The light is emitted at a specific wavelength called Lyman-alpha, produced by hydrogen atoms after they absorb energy. But what New Horizons sees seems to be shining too brightly, so the researchers think there must be another region of hydrogen contributing to the glow. One potential source is the so-called hydrogen wall at the boundary of the sun's influence, a location called the heliopause. That's where the energy of the solar wind pushing outwards is balanced by the energy of particles coming in towards the sun from the rest of the galaxy. These opposing forces result in a standstill. That's the pause and heliopause, and they create a place where hydrogen can pile up into a wall or shell around the solar system. This hydrogen wall would be emitting extra Lyman-alpha light, which could contaminate New Horizons' observations of the interplanetary medium. There's just one catch. NASA's twin Voyager spacecraft have traveled even farther into this zone, and while their measurements of the IPM match up nicely with what these researchers found, other Voyager data suggest the hydrogen wall might not be the answer. So what could be? The New Horizons astronomers aren't sure, but they plan to make more observations twice a year for the next decade or so to try to figure that out. Combine that with the data we'll be getting back from the Parker Solar Probe, and we might soon have our first end-to-end understanding of the sun from the corona to the edge of the solar system. Thanks for watching this episode of SciShow Space News. If you're interested in learning more about the scientific questions the Parker Solar Probe is looking to answer, you can check out a whole episode that we made about that from back when the mission was still called the Solar Probe Plus.